Day 8 is about union types. The part 1 cared about was making everyday values and objects carry clearer meaning. I wanted union types to read like a real engineering decision instead of a neat TypeScript demo. That is a much better use of TypeScript than just adding syntax around values we still do not really understand. My first check was give each variable and object field one precise meaning. If that part is vague, the rest of the feature is usually vague too, because the team is already arguing about a shape that was never written down clearly. The second check was let narrowing or inference remove ambiguity instead of relying on comments. That is where the type system starts paying rent. The code stops being descriptive after the fact and starts pushing the design toward a smaller set of valid states. The third check was prefer types that explain the allowed states instead of patching invalid states later. I want the next reader to see that boundary without opening 5 extra files or guessing what the original author probably meant. The first mistake I was watching for was using broad types because they feel flexible and then losing the real constraint. The second was assuming a value is present or narrowed without proving it in code. Those are common because they feel productive in the moment and expensive only later. When I like a TypeScript design, it is usually because the risky path got narrower. The implementation still has choices, but the dangerous assumptions are pinned down before they spread. If a teammate changed one field or one branch tomorrow, the type boundary should make that change safer to review, not harder to understand. That is the standard I keep coming back to because most teams are not blocked by syntax. They are blocked by unclear ownership of the contract. So the recap for day 8 is straightforward, making everyday values and objects carry clearer meaning. The practical checklist was give each variable and object field one precise meaning, let narrowing or inference remove ambiguity instead of relying on comments, and prefer types that explain the allowed states instead of patching invalid states later. When those are visible, refactors become calmer and reviews become more specific. The compiler is helpful here because it catches the disagreement while it is still cheap. Once the same misunderstanding is spread across handlers, components, or packages, the fix is rarely just one line. I also want failures to happen at the right layer. If bad input or stale state travels too far before anything complains, the type signatures may look good while the design is still leaking uncertainty. Another quiet win is reviewer confidence. If the boundary is obvious, the conversation can focus on the real trade-off instead of spending half the review reconstructing what values are even legal. That is why I keep preferring smaller explicit models over broad flexible ones. Flexible code can feel fast on day 1 and still be expensive on day 30. That is the point I want to keep across this track. The type system should reduce ambiguity before the feature grows teeth. If I had to summarize the design instinct behind this lesson, it would be this: let the type system carry the boring certainty so people can spend their time on actual product decisions. That is also what makes a codebase more humane. The next person should not need a meeting with the original author just to figure out which values are allowed to cross a boundary. The practical payoff is cumulative. One explicit boundary does not just prevent one bug. It gives the team a shared place to stand when the feature grows, the stack changes, or the product picks up another workflow. That is the version of TypeScript I trust most, not the flashy part, but the boring reliable part that keeps several moving pieces aligned when the codebase starts carrying real business weight. It also means the team can move faster without pretending every engineer holds the whole mental model in their head. The type scene carries some of that load for them.